Acha, in the last class, of fluid mechanics, what we have done? The speed of efflux we have done, no? So this class, acha, I'll tell you a concept related to it. See, there is a concept through which we try to find out the time taken to empty the tank. It will be a bit difficult for you. This is happening. Time taken to empty the tank. What's the situation? Situation is there is a tank like this, and water is coming out from it through a hole at this point. So the velocity of fluid coming out of it is v, and initially say it was at a height capital H. Now our task is to find out the time in which this tank will be emptied, right? Okay. Can you suggest me can anyone suggest me how to do it? How we'll do it? Anishka is absent again.
So we can calculate the flow rate like when.
Yes, you can equate the flow rate. Means the flow rate at this point will be equal to the flow of the liquid coming out of it. Q1 should be equal to Q2. That's the basic thing, because on which the equation of continuity works. Now, what's the flow rate? dV1 by dt, volume of flow. This V1 is what? V1 is the volume at this one point, and V2 is the volume at this point. dV2 by dt. Now but what I am taking, because see, initially it was at a height edge, but I'll take a case when this liquid is at a height of y from the bottom. So dv1 by dt is equal to dv2 by dt. Now I'll be taking the motion here. So at this point, if I've taken the area of this cross section of this whole container is capital A and area of this is small a, then what equation I can write? D by dt of A into Y, because this is the volume of the container at this instant, volume of the water inside the container at this instant. And dv2 by dt is d by dt of A into what? This x will take x, so again we'll have to write d by dt of acha, small a into dx by dt. So this will be equated with A into V. So A dy by dt is equal to AV, but I'll write negative here. Why? Because the volume is decreasing. The rate of flow, rate of the liquid is actually decreasing. That's why I'll write negative. Now we know from our earlier discussion that this velocity is equal to root 2 gy. We know from the Torricelli's law. Tanishka, you haven't seen the video na till now? Fluid mechanics.
Sir, I am watching the videos.
How many of them you have watched? Don't take lightly. Don't take things lightly. Otherwise, this exam will take you lightly. This exam is actually very, it does not differentiate between students. The thing is simple. The student who is not working hard, student who is not working to clear this examination or to score good marks, this exam will show you the door. This is not the school examination. This is the examination that you are going to write in your class 12. After your class 12, that is JEE Main, it is all India level examination. It's not your CBSE examination. You will have to outperform other students, otherwise you won't be able to do good. So you have to work harder. You are not working harder. You're not able to complete the videos only. What you will do practice. When you will do practice. I'm 100% sure that you have not solved a single question from the fluid mechanics by now, till now, from the PYQ book. And I'm not sure even that you are solving the questions from PYQ book, and what I feel, you are solving only CBSE level questions from your NCERT. And you think only by practicing them, you will be able to clear JEE Main. That's your biggest mistake. Become serious, otherwise you won't be able to do good. Zero minus root h is equal to root 2g into t. So 2 capital A by small a into root h is equal to root 2g into t. So the time taken to empty the tank is t is equal to a by a 2 root h by root 2 into root g. So I'll cancel this with this. Root 2 will come on the top. It will be capital A by small a root over 2h by g. This is the time taken to empty the tank. Okay, able to understand?
Yes, sir.
Kanishka, be serious. Try to complete. I told you in the last week after your exams are over. It's okay. Your exams are over, so it's okay to enjoy a little bit, but not this much. You have to complete. This JEE main examination is separate examination. Your CBSE exam is separate examination. No one will ask you your CBSE percentages. Even if you get 75 or 78 percentage, no one will bother asking you your marks in CBSE examination. The single thing that will matter after your class 12 is your JEE main score, how much percentile you have got, and that score depends only on how comfortably you are able to solve the JEE main level questions. Okay, think you are mature enough. Just think what you are doing and then act accordingly. If you are doing BYQs, it's okay. But I don't feel you are actually very seriously trying to complete things. And it will affect you in the long run. So time we have got. Now coming to the next part, venturimeter. The venturimeter application is actually, I have seen, means physical actual real application I have seen. I'll tell you that the case when after my college, I got placement. Means in my final year, I got placed in one company. That was a government company, Uranium Corporation of India Limited. I was a mechanical head. My branch was mechanical. You must be knowing. So there was actually everything in mechanical I used to see. Means I was the responsible one. There was a section. There were many sections in mechanical, but there was one section which was fan section. It's not a smaller fan. Usually the company was Uranium Corporation of India Limited. This you will find if you Google it, you'll find it. It will be in Jamshedpur. Jadugoda mines, they say. This is in Jharkhand. Now they used to extract this uranium. You must be knowing about uranium U-235 and all. It's not the final form they used to extract, but they used to extract the ore. You know something about what is ore?
Yes,
Yes, na? Ore is actually when they extract something, na? It's not the final form that you see U-235 in your movies and all. Everything is something. It's like metallic. The original U-235 or U-238 that comes out from the mining, it comes out from the mines. It's present in our soil or in stones. What they do, they actually create mines, go underground, and from there they do drilling and all. They find out the areas. It's a very tedious process. The geological persons, they go inside the mining. They actually identify the areas where you'll find out the ores, and from there they mark those area, and then mechanical instruments comes, and these mechanical they actually drill the hole, and the drill bit used to be of diamond one. Everything was under my control. So they used to drill it. They used to extract the ore. Ore was like this one, just very big boulders. It used to come out. Then it used to go to some other plant, Jadugoda, there. and there through chemical process they used to create a yellow cake. That yellow cake goes to Hyderabad nuclear fuel complex, and from there the actual final form of uranium is actually got, that we see that is used in bombs. But what I was saying, because it was a mine, so it is very important that the persons who go inside the mine, they are actually properly ventilated, because they have proper air. Cool air actually comes inside and this cool air goes outside. It's very important to create a proper ventilation system. For that, in various different parts of the mines, they have fan, and these fans, see, you are able to see fans are the only thing which are providing air. They are the fans, some fans are providing air and some fans are sucking out, so that proper ventilation is there in the mining. And mine is not a small place, it's very large, it's spread out in very large area. So the size of the fan should be very big. The size of the fan was so big, whenever I used to go for the inspection of whether the proper installation of fan and everything is going on, I used to sit sometimes, because I was younger. My age should be something 23 or 24, 23. So when I used to inspect, I used to sit on the blades of the fan. No one actually, no other means my seniors, they did not used to go there. Actually, what I used to do, I used to climb up, used to sit on the blades, and then I had the habit of inspecting things, whether everything is according to the calculations and all. What I am telling, where I have seen this Venturi meter, this fan is installed. Okay, like this kind of fan is there. It's very big. It's bigger. Sometimes the fan is it covers the whole one floor of the house. It's very big. Now it's very important to maintain the pressure here and here. The fan blades are there. It's very important how much pressure you are maintaining here, how much pressure you are maintaining here. Because of this pressure only, see, if this P2 is inside the mining and this P1 is outside, it has to suck the air and throw outside. Can you analyze and tell me, if the fan has to suck the air and throw outside, P2 should be greater than P1 or P1 should be greater than P2? Anyone?
To suck the air, then P2 must be less than P1.
Why?
Oh, no.
If P1 is greater than P2, then the pressure, the force will come, the air will come from this side to this side, na? Higher pressure to lower pressure it will flow. This is inside and this is outside. P2 should be greater than P1, na? Then only, actually, in your geographical phenomena, if you see how the air flows from higher pressure to lower pressure, right?
Yes.
Cold areas, which are cold areas, they have higher pressure, so the air flows from the higher pressure to lower pressure. And here also, if the air has to flow from inside to outside, means it has to suck. Acha, you are thinking it has to suck the air, means it has to suck air from outside to inside. That you are thinking.
Yes.
Oh, sorry. I said it has to suck the air from inside to outside. Then correct, na? P2 should be greater than P1. Misunderstanding. So how they used to see this pressure, and this pressure, and I'll tell you how they used to maintain this pressure difference also. this pressure and this pressure, they used, there was a, actually there was a, this fan is there. Beside that, there was a very large room. In this room, what I saw, casually I was inspecting. Because everyone, see, every other engineer also, they did not, they did not have that much knowledge. You will think that every engineer will be having a good knowledge, but usually in IITians, I have seen IITians or some NITians, I have seen that they actually, they believe, the students, they believe in practical knowledge more than the theoretical one. Mostly students actually tend to qualify the examination, but they do not have practical knowledge. They're actually not able to apply in the real life. But IIT, in IITs, they teach us to do like that. So inside the room, what was there? I have seen there was a very small tube, U-tube, very small. It was fixed to the wall, very small, and no one was looking at it. No one used to look at it. There were workers who were telling me, pressure, is the pressure all right? Then I would say, how you are able to see? They, by experience only, they used to say, one person was sitting inside, or means he was holding something else, some flag or something. One person outside, on the basis of the flow of the that flag, they were deciding. But I said this is wrong. When I entered into the room, I saw there was a U-tube, plastic U-tube, which was fixed on the wall, and there was, this value was changing, this thing. Then I understood, oh, this is the venturimeter kind of thing. The pressure, this pressure P1 is actually coming here, this pressure P2 is actually coming here, and the difference of this pressure P1 minus P2 is actually giving me this height difference, rho gh. We actually know, na? We know this concept. P2 minus P1 is equal to rho gh. So then I calculated, and then actually even senior, the mine manager, he was mining engineer. He actually, out of curiosity, asked me what I was doing, what kind of calculation I was doing. I was doing calculation. I found out the this pressure difference, and then I told them, I saw in the manual how much pressure difference was required, and then I told, you are doing correct. This pressure difference you are maintaining is right. Actually, they are experienced workers. They are doing from many years the same thing, so they actually tend to do right thing. But according to calculations, also it should be correct now. Then and there only I took a pen and paper, done the calculation, found out the pressure difference, and found out it's the right pressure. I did not get the exact value, but more or less the same value. So I found out this pressure difference is right. But the thing is, this, for the first time in my life, I have seen the real life use of this venturimeter that we are going to study now. Understood?
Yes, sir.
And the interesting thing is, you will be able to see these only when you are a mechanical engineer. You will never see in computer science. In computer science, your task will be only work from home maximum times, or maximum times you'll be going to office also. There also you'll be having desk job. With engineer also. Acha. Now let me tell you about the venturimeter. What the venturimeter is actually. But in this plant, in the uranium corporation, this uranium dust was actually harmful. It was radioactive. So the average life there I've seen was only 60 or 62. People did not used to live more than that. That also I found by curiosity. Once I asked, there was one very senior foreman who was under me. I asked him, why actually I'm not able to see any old age person here in the plant or in means outside in the colonies. Then he explained me, then he told me, because of the radiation, it's harmful. This is Venturi meter. Now, in the Venturi meter, see, the things are, what is this? This is velocity V1. This is velocity V1. Let's say the pressure here is P1. Pressure here is P1. Pressure here is P2. And let's keep one more height difference to here. Let's say it is X. Now, can you the area? The area of this section is A1. The area of this smaller section is A2. Now, can you give me the equations, because you have learnt by now equation of continuity and all, equation of continuity and Bernoulli's theorem. Can you give me the equation of continuity here? Haripriya, Diva, Kanishka, anyone? Give me both of the equations. Equation of continuity and Bernoulli's theorem also. Give me both of the equations. Equation of continuity and Bernoulli's theorem also. What is this? You're thinking so much. Equation of continuity will be A1 V1 is equal to A2 V2, na? This is area. Velocity is here V1. Here in the smaller section, area is A2. Velocity is V2. Density is same for the liquid. Equation of continuity will be A1 V1 is equal to A2 V2. Okay. Now coming to Bernoulli's theorem. What will be Bernoulli's theorem? P1 plus half rho V1 square plus because see this one, this section, if we take the bottom, this section and this section, they both are at the same height h. If you want to write, you can write, but not necessary. Rho gh is equal to P2 plus half rho V2 square plus rho gh. Don't worry about these pressures. These pressures will just confuse you. Okay, anyone having doubt anything? No, na? Clear? Acha, now tell me, can I find one relation between pressure P1 and P2 in terms of H and X? Or can I find the relation between P1 and P2 in terms of H? Think. Let me tell you about the task in Venturi meter. Our task in Venturi meter is to find out the velocities V1 and V2, both the sections. Not able to see. Haripriya? Viva? No one. Okay, let me tell you. See, the pressure at the top of the top of each limb is P naught because it is open to atmosphere. Now, if we take the left limb, what will be the pressure P1? P naught plus rho g h plus x is equal to P1. The first equation. Now, if we take the right limb, what would be pressure P2? P naught plus rho gx is equal to P2. If I have to take the pressure difference P2 minus P1, what it will be? Do 2 minus 1. So you will get, no, I will have to take P1 minus P2. Which is rho gh. So I'll make use of this thing, put in the second equation. This is first. Oh, sorry. I have written first and second equation there. No? So let's write it as 3. Let's write it as 4. Rho gh will cancel here. P1 minus P2 is equal to half rho V2 square minus half rho V1 square. P1 minus P2 is rho gh. Half rho into V2 square minus V1 square. What is V2? I can write V2 is equal to A1 V1 by A2. Half rho V1 square into A1 by A2 whole square minus 1. Rho gets cancelled. V1 square is equal to 2GH by A1 by A2 whole square minus 1. So V1 is equal to root over 2GH by A1 by A2 whole square minus 1. This is V1. If you want to find V2, V2 will be A1 by A2 into V1. This means A1 by A2 into root 2GH by A1 by A2 whole square minus 1. These are your velocities. Clear? Will you be able to do the question on this? Okay. Try this. If you want to see something in the above, what I have done, just ask me to scroll it up. Otherwise, okay, try solving it. नहीं 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 यार, आंसर तो अलग आ रहा है। यहाँ एक मिस्टेक हो गई हमसे, इसलिए अलग आ रहा है। तो गड़बड़ हो रहा है यहाँ पे। ये P2 है, ये P1 है। P2 प्लस रो मरकरी GH ठीक है, इज इक्वल टू P1। हाँ, ये मरकरी और इसका खेल हो गया था। तो रो मरकरी इंटू G इंटू H इज इक्वल टू हाफ इंटू रो वाटर इंटू V2 स्क्वायर माइनस V1 स्क्वायर। अब ठीक है, तुम लोगों का भी नहीं आएगा अभी तक? You also did not get the answer till now. अरे प्रिया, दीवा, आंसर नहीं आया अभी तक?
No, sir.
This one. So 5 into 21 by 4 into 136. This will be 1.97 centimeter. 1.97 to something. Wait, let me calculate it. This is how we do it. Divided by 4 divided by 136. 0.193. 0.193. So I can write it's 1.93 centimeter. Did you understand the solution? See, the only thing is here everything was right because they have given the Q was same, the area, the rate of flow was 500 centimeter cube per second, that is equal to area into velocity. So using that, I have found out the area was given to me. So using that, I have found out the velocity V1 and V2. Now only thing is I have to find out the pressure difference, because see, pressure here is P1. So the pressure at this on the left limb at the top surface will be P1. On the right limb top surface will be P2. The difference of height, suppose, which they are asking, it's h, suppose. So P2 plus rho mercury. But earlier what mistake I did? This is mercury, I forgot. P2 plus rho mercury into G into H should be equal to P1. The pressure in the same liquid here. So using that, I'll find P1 minus P2. This relation. That I have kept P1 minus P2. That value I have substituted in the Bernoulli's theorem. That's all. Over. Easy? Understood?
Yes, sir. I
What?
think I made a mistake while eliminating. I didn't like calculate properly. I followed this same steps only, but
Some silly mistake you have done. What about you, Haripriya? Haripriya is there or not? She slept or what? That's the problem if we keep the classes that night. Kanishka, what about you?
Yes, sir.
Hmm. Did you solve it?
Yes, sir.
Hmm.
My answer was wrong.
Achha, okay, good. Very good. Haripriya is slept, I think. Is in the class, but after this, I'll teach you the application of Bernoulli's theorem. But I think it will be done in the next class. Application of Bernoulli's theorem is the Magnus effect and all. Uh, Airlift, Magnus effect, that's all. Those two things. And then we'll move on to the viscosity and all. Viscosity, terminal velocity, and surface tension. This we'll do in the next class. Okay, let's end it.